All right, so 12C, another related rates problem. It says a hot air balloon is rising straight up from level field that's being tracked by a rangefinder 300 feet from the liftoff point. Let's draw a picture for this one. So the rangefinder is going to be here. The rangefinder is 300 feet from where the liftoff point was. So you got a balloon that's up here. So this is the liftoff point, so we have that. So we have a right triangle that we have dealing with here. The diagonal distance between the rangefinder and the balloon is increasing at a rate of 12 feet per minute. So let's go ahead and put some dimensions on here. Let's call this y, and then let's call this z for that distance. Okay, so that way we have some variables that are in there. So the rate that the distance between the rangefinder and the balloon is increasing, that's going to have to do with the z, because that's the actual distance there. It's not going to be along the ground. That part's not going to change. The liftoff point is always the same. It's this distance that's going to change because that balloon is rising, and so the z is going to be getting larger as it goes on there. Okay, so what they're telling us is dz dt, based on the variables that we have set up here, dz dt is 16 feet per minute is what we're told there. It says find the rate that the balloon is rising. So that's going to be the dy dt is the unknown. When the height is 400 feet. So the height would be the y. That's going to be 400 feet right there. So we have to figure out the formula that's going to be used. If you have a right triangle, then you want to use Pythagorean theorem almost always for these kind of problems. Let's do that for this one. You're going to do 300 squared plus y squared, and that's going to equal z squared. We're going to take the derivative of all this with respect to time. Now, if you do the derivative of this one, that's just going to give you a 0, because 300 squared is going to be a constant. So that one, the derivative of that just goes away. We don't need to worry about it. But the other ones, you have 2y dy dt plus 2z dz dt. That's going to be the main formula that you're going to work with here. And of course, if you wanted to cancel out that one, you can. This will be equal sign, not a plus. Okay, so we got 0 there for this one, and we have this part, you have equals, and then you have that part right there. Now, if you want to cancel out the 2's from both sides, you can do that to make the numbers smaller. But let's go ahead and put in the numbers for each one so that we have them here. We have 2 times 400. 2 times 400, and then dy dt is the unknown. That's what we're trying to solve for. On the other side there, we have this. Now we have to find out the z. Now you can do that by using this formula here. If we do that off to the side here, we have 300 squared plus 400 squared equals z squared. And so if you were to work through all this, you get 900 plus 1600 equals z squared, 2500 equals z squared, and then taking the square root of that, for that one, you're going to get 500 as a result. Okay, so z is equal to 500. That's what you can put in right here. Let me move this up here so we have some more space. So we have 2 times 400. 2 times 400 dy dt is going to equal 2 times 500, we said, and then times the dz dt was 16, so we put that in here. Now we have to solve for the dy dt. So solving for that, we're going to get 800 dy dt is going to equal 16 with that, so it'll be 16 with 3 zeros, 16,000. Divide both sides by 800, and your dy dt, when you divide by that, is going to give you 20, and that's going to be feet per minute would be the units that you have on that one. So this right here would be your final answer.